All right, let's go ahead and get started. Welcome everyone to today's Tridium Talk. This is Mike Smith, Product Manager with Tridium, joined today by software engineer Patrick Sager. We also have a few members of our cybersecurity team on the call to help answer any questions you may have. So today's session is going to be focused on module signing. We're going to start with a brief overview and some requirements before we're going into a live demo on signing and installing modules. So a couple of housekeeping items to start off with. The session is going to be recorded and will be available on the Tridium events webpage on the link that you see on the screen. All attendees are going to be muted during the session to enable us to cover as much content as possible. So feel free to use the Q&A box on the screen to submit any questions you have, and I see some rolling in already. And we'll reserve some time at the end to address as many of these as possible. So we'll go ahead and kick things off. And Patrick Sager, if you want to take over and get us going.
All right, thanks, Michael. Good morning, everyone, and thank you all for joining today. My name is Patrick Sager, and I'm a software engineer here at Tridium. And like Michael said, today we're going to be talking about code signing and its benefits and how module signing works in Niagara. So first of all, what is code signing? Code signing is the process of applying a digital signature to a piece of code so that it can later be verified to confirm that it came from a trusted source and that there have been no unauthorized modifications. Here's how it works. First, we start with a piece of code and send it through a cryptographic hash function. The goal of this hash function is to create a unique fixed-sized hash for a given input. Any two different inputs should result in a different hash value. We then sign that hash with the private key of our certificate and take the resulting signature and bundle it with the original code along with our signing certificate. When it comes time to verify the signed code, we send the code through the same hash function, producing the same hash value. Then we verify the signature using the public key of the signing certificate and confirm that it was generated for the provided hash value. If someone were to modify the code, it will result in a different hash value, causing signature verification to fail. There are several benefits of code signing. The first is that you can confirm that code is from a trusted source based on the certificate it's signed with and ensure that it doesn't have any unauthorized modifications that would have caused verification to fail. The second benefit builds on the first. If you're only signing code from trusted sources, your risk of installing malicious code is going to decrease. And the third benefit is that due to the risks of installing unsigned code, IT and business security requirements are going to start requiring code signing. A system that allows the installation of unsigned third-party code will start to be considered vulnerable and requiring all code to be signed will satisfy these requirements. In Niagara, module signing requirements are controlled by the module verification mode. There are three possible module verification modes: low, medium, and high. With the low verification mode, third-party module signing is completely optional. You'll see warnings for unsigned or untrusted modules, but they can still be installed. With the medium verification mode, modules must be signed by a trusted certificate. This can be a self-signed certificate, but it will have to be installed in the user trust store of any platform where the module is installed. And with the high verification mode, modules have to be signed by a CA signed certificate. An internal CA can be used, but again, it'll have to be installed in the user trust store wherever the module is installed. Third-party module verification was introduced in 4.8 with the module verification mode defaulting to low, meaning module signing was optional. The verification mode could be increased to medium or high on a per platform basis using the system.properties file if desired. In 4.9, the module verification mode was increased to medium, requiring module signing by default. The verification mode could be increased to high or decreased to low if needed using the same system.properties file. Now, those who have seen previous module signing communication from us have probably seen that we previously indicated that we would switch the default module verification mode to high in some future version. We've since decided that a default of high is probably too restrictive, And so we've decided to keep the default at medium for the foreseeable future. Now, I'm not going to say that we're never going to switch the default to high, since security requirements can change and require us to do that, but we have no current plans to do so. We will, however, likely restrict or remove the ability to reduce the verification mode to low in a future version. This version hasn't been determined yet, but it will certainly be later than 4.10. Now, though we don't plan on requiring it yet, we do still recommend that developers sign their modules with a CA-issued certificate to make distribution easier. If you use a certificate issued by a publicly trusted CA, the module is just going to work out of the box, and you can install it in any case without having to worry about distributing certificates, your self-signed or internal CA certificates, to your customers to have them install them on the platforms before your module will work. Now I'm going to give a demonstration on some of the module signing features in Niagara. All right, so I have here a 4.9 Workbench installation. And the first thing I want to show you is the module info tool. Now this tool was introduced in 4.8, and basically it just gives you a list of all the modules you have installed and information on the signature of those modules. So if I sort by version here, you can see that I have several non-stock modules added to my installation. And they all have a red X to them, indicating there's an error with that signature, so that it will not work currently. Now the theme of these icons is that a green icon means that module is good to go and should be good for as long as it lives, and nothing will change that. A yellow icon means that it's good in the current version, but there may be some issues with it that could cause it to fail in the future, or if the module verification mode is changed. And a red icon means that there's an error and it has to be resolved before the module will work in the current version. So let's just take a look at one of these. Look at this one first. So we can see that this, if we look at the details, this module is signed, but there is a warning and an error. The warning is that it's signed with a self-signed certificate. So if we were to increase the verification mode to high, this wouldn't work without being signed with a CA-issued certificate. And the second error is the signer's certificate path could not be validated, which generally means that you need to install a certificate into your user trust store. So we'll do that here in a minute. A couple other modules here. We have an unsigned module. So you can see that's our warning, and we don't see any certificates there that it is signed with. And this one is actually an invalid signature. So this I would consider the most severe error. This means that the module was signed, but something has changed, causing that signature to be invalidated. So this is the thing we're trying to catch with module signing and verification. So we know that either someone deliberately modified this module to do something malicious, which is what I did to cause this to fail, or something happened in transit. Maybe the file got corrupt or something, which is probably less likely. But anyway, we know that there's something wrong with this module, and we need to go and get a good copy of it if it's or it's just purely from a bad actor. All right, so to resolve some of these issues, we're going to go ahead and import the certificates that these modules are signed with. So I'm going to go over to Certificate Management into the User Trust Store tab, and I've already exported the certificates for these modules. If you got your modules from a developer, they would, and they're not signed with a publicly trusted CA, hopefully they included certificates with them. Or if you are a developer, I'll show you how you would export your signing certificates in a bit. So I have both of these certificates already exported, so I'll import these. And then if I go back over to my module info tool, I can see that one of them turned yellow and one of them turned green. With the yellow one, like I showed you earlier, there's still this self-signed warning, which is fine for now and probably for all future versions, like I mentioned. This CA signed one is all green since even though it's an internal CA, it satisfies the high verification mode as long as that internal CA is installed in the trust store. Now, one thing that I also wanted to point out, we see these statuses here. Now, if I were to do anything that would trigger one of these modules with errors to load, like opening a palette for that module, it's going to fail to load that module. So I'll just demonstrate that here on the unsigned module. We see that we got an error loading palette, module unsigned, failed signature verification or validation. Module's not signed. So that gives a fairly descriptive reason for that. But if we were to go ahead and try to open the palette for one of the signed modules that we just imported the certificate for, that works, and we see we have a palette with one item in it. Now, at this point, there's another issue that many users run into where they expect to be able to use this in their station now. And if I try to drag this component from the palette into my station that's running locally, I get a drop failed, missing module. So that seems kind of weird, even though I just imported that into my trust store, it's not working. The reason for this is that there are separate trust stores for Workbench and platform. And even if we're running this Workbench in the same installation as we are the platform, and this has been a thing since 4.0. So we have to make sure that we install that certificate on the platform as well. So I will open the platform, user trust store, and import both of those certificates. So this is where distributing these self-signed or internal CA certificates can get very tedious, and that's a big reason for why we recommend developers go for the publicly issued CA certificate. But at this point, I should be able to add my component to my station, and there we go. All right, now as I showed earlier, there is an unsigned module in here. And you may run into a case where you have an unsigned module and for whatever reason, either the developer isn't actively maintaining it, or they just are distributing unsigned modules and haven't gone through the process of signing them yet, but you need to sign them before you use it. So for this, we have our jar signer tool that you can use for actually signing a module through Workbench. To do this, we first need a code signing certificate in our key store. So we can just generate one right from certificate management. If you already have one that you want to use, you can import it just like you could import any other TLS certificate or anything like that. You just have to have the PEM file with the private key and the certificate in it. But we'll generate one real quick now. Make sure you select code signing for the certificate usage, or you won't be able to use it in the jar signer tool. And you need a password. All right, so that generated. Now we'll go ahead and export the public key so we can use that. Because again, the certificate has to be in the trust store. So we'll import that in our user trust store as well. Now, if we open up the jar signer tool, we can go and grab that jar from the modules directory. Unsigned. We'll choose a certificate to sign it with, the one that we just generate. Give it our certificate's password. And we'll leave this default TSA URL so that this module gets timestamped. I'll explain that a bit more in a minute. All right, now we're just gonna pick a place to save it. So we'll save it right back over the original jar and overwrite that file. Ooh, uh-oh. Okay, that file is open in my current install, so I'm gonna have to save that somewhere else and then copy it over. Okay, so I signed that, and since it's open in Workbench, I'm gonna have to go ahead and close Workbench before I overwrite that old module. So I'll just go to where I saved that, which is right here. And then paste it in here, overwrite the existing one. Then I'll restart Workbench. Okay, so we can now see that this is signed. It's still a warning because it's signed with a self-signed certificate. But again, if we were to go and also again import that certificate into the platform, we could use this module in our station. Now I want to go look at, if we click on this link here, it's going to open up the certificate that this module is signed with. And we can see all the details about the certificate. One thing I want to draw to attention is the expiration date, also known as not after. So you can remember that is the certificate is not valid before this date. That's the generation date, and it's not valid after this date. That's the expiration date. So we can see this certificate, since I generated it just now, it expires in a year, so November 12th, 2020. Now, since we timestamped, we enabled timestamping when we signed this module. What that does is it reaches out to a trusted timestamping server. We sign the module first, we reach out to that timestamping server, provide it with a hash of our signature. It actually signs that with some additional details, proving that it was that the signature was generated at the time that we made that request, and embeds that in the signature. So through our verification process, we can confirm that this module was signed on this date at this time. Now, since the certificate was valid when the module was signed, when we go to verify that, we even past the certificate expiration date, that verification will still succeed since there is proof that it was signed while the certificate was still expired. So you don't have to go and re-sign all your modules when your certificate expires, as long as you use timestamping. A lot of people have been confused about that, but as long as you timestamp, once you sign it, it should be good forever. Now we can tell that we timestamp this because there is no not timestamped error. If it wasn't timestamped, there would be an error in this dialog here. But or or a warning that it's not timestamped. But since we don't see that, we know that it is timestamped. All right, and with that, I want to walk through the process of installing signed modules on a JACE. Now, it's actually a bit more straightforward on a JACE because in the Windows platform or supervisor platform, since those modules get copied through just the standard Windows file system, there's a lot more gray area, and you have the module installed, but you can't use it yet because it's not trusted yet. For the JACEs, since we go through our standard installation tools, we're actually going to prevent you from installing those modules if they're not going to work on the JACE. So it's a lot more clear whether the module is actually going to work once you get it installed. So we'll go ahead and open a JACE here. And open up the software manager. And just like in the module info tool, we have all these icons indicating our signature status for all the available and installed modules on the JACE. These statuses were also added in 4.8. So if we take a look at those same modules we were looking at earlier, they have these same errors, just like we did before we installed the certificate in our Windows platform. And that's because these certificates are not yet installed on the JACE. So yeah, and if we double click on this, we can see a similar dialog that shows those errors. So if we open up certificate management of the JACE and open the user trust store, and we'll install all of these. Oops. Now, I didn't actually show you what would happen with those other modules if you tried to install them with a warning, but I'll use this invalid signature module and show you what happens there. Basically, we just get an error dialog, and we can't actually install it. But if we install these ones we just imported the certificate for, we just get a warning for those two that are signed with self-signed certificates, but we can still continue since that's okay for now. And it goes ahead and installs those. Now you'll notice that we got a question mark for the status on the installed version. That's the version that is currently present on the JACE. This can be a bit confusing, but the reason for this is that on the JACE, we have a cache of the signatures of all the installed modules, but that cache can be quite CPU intensive to regenerate if there are a lot of modules to reload. So we only reload that cache at startup of the platform or the station. So it's okay when these are a question mark, because when we ultimately load those modules in the station, that they get independently verified, independent of that cache. But if you see the status, you can resolve it by either restarting your station or rebooting the platform, and it will resolve to the proper status. So at this point, we can go ahead and open our station. And we can, from that same self-sign module that we were using earlier, we can stick that component in there, and it all goes through. All right, so at this point, I want to move on to the more developer geared section of my presentation. So I'm going to walk through how you can configure the Niagara developer environment to sign your modules at build time. So let me close Workbench here. And I have a project opened up in IntelliJ. So this is just a very simple Niagara module that just has one dummy component in here. And I haven't done anything special. This is just out of the box. So if I just run the jar task, we'll see what happens with that module. All right, so that finished up. Let's open up Workbench and take a look. All right, we'll open up that module info tool again. Okay, so signing demo is the module that I just built. We see it has a red status, but if we open it up, it's actually already signed. So what the Niagara build process is going to do is if you don't have a specific certificate configured, it's just going to auto-generate one for you. It's just going to be an auto-generated self-signed certificate. It has some, it's based on your user ID of your machine. And your module gets signed with it. Now in development, you can, just while you're testing your module, you can just go ahead and use this. You can either export that certificate from the key store that it gets generated in, or you can just copy this PEM, save it off to a file, and re-import that through your certificate management in your trust store like I showed you earlier. So that's probably fine for a lot of people just during development until they're ready to release and want to sign with their release certificate. So once you are ready to sign with a different certificate, I'll go ahead and show you. And let me open Workbench back up, sorry. All right, first I have to figure out how to move this bar that is in my way. Hide floating meeting controls, there we go. All right, so if we open up the help guide, we go to Duck Developer, Security, Code Signing. We have a guide here on how to set up this signing profile to sign your modules at build time with a configured certificate. So we're going to follow this here to do that. So first, I have my console pointed to my Niagara user home directory. And I'm gonna, and this can, you can really create this anywhere. You just have to make sure you point it to the right location. But I'm gonna copy and paste this. And I'll explain the details of this command here. So key tool is a built-in tool of the JRE. It comes from Oracle. And you can use this to generate keys and import them into Java key stores. The gen key command obviously generates a key and a certificate. The alias is just the alias you want that certificate stored in the key store. Algorithm, typically RSA. The extended key usage certificate extension. For Niagara, we require code signing certificates have the code signing extended key usage. The validity is just how many days until that certificate expires. and the key pass and store pass are just what passwords the key and key store are encrypted with. And of course, the key store is just the file location of either an existing key store or a new key store that you want to create. And we're creating a new one here. So if I hit that, it's gonna prompt me for some information that I want in my certificate. So I'll just fill that out real quick. Okay, and now it's generated a key with those, or a key and certificate with those details for me. So at this point, we need to create a signing profile.xml file. Now this has to be a peer to that key store, and it has to have the same file name as that key store with just the XML extension instead of the key store extension. So I've already created this file and have it ready to go. You can see that I've also added the timestamping section, which is explained further down here in timestamping. So I've already done that. Now I also need to configure the build to use that signing profile. You can either do it from the command line or using the Gradle.properties file, which will make it permanently use that until you change it or specify a different one through the command line. So I'm going to go ahead and do that. I have my Gradle.properties file open. Now, this Gradle.properties file isn't automatically created. If you don't have one yet, it's in your, if you look up here, you can see where this is. It's in my user home, my Windows user home, not Niagara user home. Windows user home, the .gradle directory, which should get automatically created when you do a build, and just Gradle.properties. So I already have this line ready to go. I'm just going to comment it out. Niagara.signing.profile. A couple of things to note. It does have to be an absolute path. It does not support relative paths. At least when you're specifying it in Gradle.properties, this doesn't apply to the command line, but in Gradle.properties for Windows, you have to use // for the file separator. So we'll do that and save and check out what else we need to do. All right, next we need to specify the certificate alias. When we generated that, we used the mycert alias. So you can either do this in build.gradle, which will apply to all your modules, or if you want specific modules to be signed with specific certificates, which probably isn't likely for most people, you can do it individually in the modules Gradle file. But we'll just do this in the build.gradle file. And again, I've already done this and just need to uncomment this and save that. Now, another thing to note, the changes made to Gradle.properties will not take effect until you restart the Gradle daemon, since the Gradle daemon caches those. So for that to take effect, just from a Niagara command line, just run Gradle w -- stop. And at that point, future builds will have those new Gradle properties take effect. So at this point, we should be able to run the jar task and have that module signed with our new certificate. All right, so that completed. So let's take a look at our module info tool again. Signing demo. Okay, we can see we have a new certificate here with the details that I entered earlier. Now, of course, since this is a self-signed certificate, we do need to, again, import that certificate into our user trust store. So we can either just copy it from this view, which is fairly easy, or there are also details in this help guide under establishing trust that demonstrates how to export that certificate from the command line. So just to show you a different way of doing it, I'll go ahead and do that now. So again, this is just another key tool command, and it's just going to export the public certificate to a PEM file. So at that point, we can open certificate management up, user trust store, import. So it's going to be in the Tridium directory here, since that's where my console was pointing to, and there's the mycert.pem file. And those are the details of the certificate I generated. So we'll click OK. And if we go back to our module info tool, we can see that the signing demo module is now yellow with just the self-signed warning. Now there are some additional details in here on creating a certificate signing request from that certificate we generated. So you can either sign it with your own CA, or you can send it off to a CA who's going to, a publicly trusted CA who's going to issue a certificate. We've found that most CAs tend to follow their own process for generating and getting that certificate signed and imported to however they're having you store your keys. So you'll probably have to follow a different process than this. And most CAs should have some documentation or a help guide on how to get your certificate and key imported into a Java key store. So you need to follow that information, and once you ultimately get your certificate and key into a Java key store, you can create the signing profile XML file with the relevant details for the store pass and key pass, etc. Now there are a few kind of gotchas here that several developers have run into when going through this process. So there is a code signing tips and troubleshooting guide that we've written and posted to the Niagara community. To find this, you can just go to the Niagara community and search code signing tips. But I'll go through a few of them here just to highlight them. So first is we are currently not recommending the use of Java's built-in jar signer tool. We've previously, prior to 4.6, we've recommended the use of this for those that have certain permissions in their module that require signing before the additional signing features were implemented. But several developers had run into issues where with certain CA issued certificates, jar signer would embed the certificate chain in the incorrect order in the module. And then when we go to verify that module, Tridium could not handle that, or Niagara could not handle that incorrect order. Now this affects 4.8 and 4.9. 4.10, a fix was added to be tolerant of the incorrect order that jar signer would embed with. So if you're creating modules that are just for 4.10 or the future, you should be okay using jar signer, but anything earlier and you may run into issues. Another note, I showed you that section on generating a CSR. The command that is copied in there for generating the CSR did exclude this extended key usage option. So depending on the CA that ultimately signs that CSR, if you don't include this, your resulting certificate, signed certificate, may not get the extended key usage extension. So if you do generate a CSR this way, make sure you include that. Like I mentioned, when you do get a signed certificate, you'll have to import that into a Java key store that you use to configure your signing profile, and it just depends on what format your CA gives you your certificates in. So there are a few details here that that may help with various formats of these certificates, may help to import that. The most important thing to know is you need the private key and you need the full certificate chain, including your end certificate, any intermediate certificates, and the root CA certificate. If you don't have all of those, they're not all going to be embedded into the jar, and Niagara won't be able to verify the certificate chain because it won't have all the information it needs. So you can read this and make sure that you do include the full certificate chain. Like I mentioned, most CAs should have documentation on importing this into a Java key store, because that's one of the main use cases for a code signing certificate, is to sign jars. So you can follow that documentation and update your signing profile with the relevant information. The next note is special characters. If we look at our signing profile XML here, like I showed, we add the key store and the key and key store passwords here in the XML. Now, of course, since XML has special meaning characters, I can't just use I can't use any angle brackets or anything that like that raw in my XML, because that's gonna try to be processed as an XML special meaning character. So any of this list of characters can have problems in the key and store passwords. So you can either just avoid using those completely in your passwords, or if you do use them, use this table here to escape them in the XML. And then we have a general troubleshooting guide here with several common errors that that can happen while setting up this process, and some common causes and solutions for those. So like I mentioned, this is available on the Niagara community. So hopefully that can help with any issues people run into. And at this point, I'm done with my demo. So I will go ahead and start to open this up to some questions.
Thanks,
All right.
Patrick.
Yep, no problem.
Yeah, great job. A lot of good activity on the Q&A here. Looks like there's about 27 questions that we provided answers to. A couple offline questions that I have in my notes here. Can we use a self-signed certificate for production, and is that safe?
Yes, you can use a self-signed certificate for production. Like I mentioned earlier, we currently don't have any plans to start requiring CA signed certificates by default. So that should work for the foreseeable future. As far as if that's safe, that's going to depend on how you protect that self-signed certificate. So obviously, if you're just generating a new one each time and sending that off to whoever and then doing whatever with it, then that can cause problems, because you don't want the process to be, here, I'm sending you a module and this is the certificate that it's signed with, because if somebody else, some malicious party, sends someone that module and they have a habit of just installing the module and installing the certificate, that kind of defeats the purpose. So ideally, you would have, if you were going to use self-signed certificates, you would ideally have one certificate that is intended for releases only, and you shouldn't sign with that certificate during your development and testing. That certificate's private key should be locked down so that only a few key developers have access to it, or ideally your build process would be one of the only things that has access to it, so you won't leak that key. And you want to communicate to your customers that this is our release certificate. If you get something that's signed by anything other than this, be wary of it and check with us to make sure everything's okay. So that process can work, but like I mentioned, it's going to be a lot easier workflow if you use a publicly trusted CA issued certificate. So we recommend most developers go through that relatively minor cost of getting a CA to issue you a certificate. But it is possible with self-signed certificates.
Okay. There is a certificate a Tridium certificate installed on the system, that there's a question if they can use that one to sign.
Yes, I saw that question in the same list you're looking at. No, that certificate is for, that's the auto-generated certificate used for FOX-S and HTTPS communication. It's a TLS certificate and has no correlation to the code signing certificates other than it is also a certificate. But you can't use that to sign code because it does not have the code signing extended key usage. So no, you'll have to generate a separate code signing certificate, which like I demonstrated is relatively easy through Workbench.
Okay. Can I update a module signed with a now expired certificate with a new version of the module signed with a new certificate?
Yes. So hopefully I cleared up some things on the expiration when I explained expiration and time stamping. So basically, once you sign something with a certificate, like I said, if you time stamped it, it should be good essentially forever. And you can continue signing your module with that certificate until the certificate expires. Once that certificate expires, the modules you've already released, since they're time stamped, are still good. But any new builds that you have to do, you have to have a new certificate to sign any new release modules. So basically that's the cutoff. When it's time to build a new module, you need to use a new certificate, but the old modules will still continue to work as long as you use time stamping.
Okay. All right. This question here, do I need to sign the program module made with program object?
Okay, so yeah, I didn't cover that in this presentation, but we do have the program object signing, which was implemented, I believe, in 4.3, but we still are not requiring that by default. Now, program modules are actually treated no different than standard third-party modules. Even though it's based off of a program object, in reality, it's indistinguishable from a module once it's built. So you do have to have those signed with the trusted certificate. And I'll actually, the program modules, we have some documentation on how that gets signed, but basically you'll generate a code signing certificate the same way I showed earlier. And we have a, if you go to options here, code signing options, this controls what your program objects and program modules get signed with. So if I just choose that certificate there, now any program object or program module that I sign with this instance of Niagara is going to sign with that certificate. So that's how you do that. But anything else with a program module applies just like all of the other things I talked about with standard third-party modules.
Great. Thanks, Patrick. Hopefully everyone has found this informative and helpful. The recording would be available on the links provided, and we will also share the Q&A results within the next week or two. So thank you so much to Bill and Melanie on our cybersecurity team for joining in and answering some questions as we were live. And Patrick, thanks so much. Great job. And again, hope everybody found this useful and informative. And we will follow up with getting this stuff posted. Patrick,
Thanks
any final thoughts?
for joining, and yeah, I hope this clears up some of the confusion around module signing. I know it can be a bit of a hurdle to figure out, but hopefully this clears a lot of that up.